Cool. 858, mirror reflection. There is a special square room with mirrors on each of the four walls. Except for the southwest corner, there are receptors on each of the remaining corners, numbers 0, 1, and 2. Southwest, yeah. The square room has walls of length P, and a laser ray from the southwest corner first meets the yeast wall at a distance Q from the 0 receptor. Return the number of the receptor that the ray meets first. Wow. Okay. I mean, this seems very geometry-y, but it actually probably is, what you call it, um, uh, uh, a number theory type thing with GCD. Yeah, let's think about this. So what number, or like what's the I'm just kind of talking through my process of trying to figure out this problem. I do not for this problem have like an immediate like I don't immediately know, be like, oh yeah, it's just this algorithm. So I am trying to talk through it a little bit. So I think my first condition, or me trying to think about it, is my approach is like, okay, what condition will it hit 0 first, right? Um, so it will hit 0, then if what's p and oh, if maybe that's a. I mean, I think 0 and 2 are symmetric. I mean, that's kind of obvious. Of course, diagonal. So like that means yeah. So maybe it's more interesting to see what will hit the receptor 1. So it hits 1 if hey Johnny One Man, yeah, these things are always tricky, but it is the medium, so it should be figured out. And P and Q is over 1,000. But but okay. So it hits 1 if P is equal to Q. I think that's an obvious ish case. But also if let's see, I'm drawing a little bit on my piece of paper, but where 1, 2, 3. So like if P is an odd multiple of Q, then it should also go to, or the other way around, go to 1. And then in all the other cases, it's 0 or 2. Okay. Is that enough? Because definitely, well, I mean, that's technically true, but is that enough? Well, we're thinking about that case right now where one of the numbers is 1, but what happens if they're, okay, well, if the numbers are equal, then that's also very obvious that it goes to 1. And then from that, the induction is from 1. If 1 is an odd multiple of the other. But my question now then is what happens if and you could do some math with kind of the GCD and kind of figure that out. So that's not that difficult. But what happens if 1 is like 2 and the other is a 3? Right? These things are tricky. What's a P? Oh, maybe I'm saying all these. I think I was thinking about it a little weird. So I think. So P is always going to be the bottom. So Q, I guess, is just. I guess Q cannot be on the top wall then, in that case. Okay. Screen P and a laser wave from me to east wall at a distant Q from the zoom. I mean, that's also like an awkward way to draw it, right? Because in theory, you could bounce off the top and then go up, down, up, down, up, down, then hit the Q, right? Okay, but let's focus on that for a little bit. Maybe I'm misunderstanding it. Also, the only Like what happens when, well, I guess Q cannot be bigger than P, I was going to say, technically. Okay, so if P and is equal to Q, then clearly we receptor is 1. And if if Q, oh sorry, if P is the multiple of Q that is odd, then it will also hit 1. Wait, let me look at the constraints. Maybe I'm being dumb. Okay, so Q is always less than P. So in that case, okay. But so we established kind of what happens if we kind of, but what happens if it is the GCD is not 1, right? Meaning, or sorry, the GCD is 1, but like what happens if P is 3, for example, and Q is 2, right? That means like there's a lot of bouncing back and forth. But what does that mean for us practically? Okay, let's kind of draw this out, and then it bounces up to the top, and then and a technique that you could think about is that you do a reflection on top. So for 2, that means it'll bounce back to the left 4 at 4, and then it'll bounce to the right at 6. And because each thing is 3, is there any case where, I guess when Q is 0, but is there any case where, because Q is always less than P, is there any case where we could get to 0 other than Q is equal to 0? Maybe not. And in that case, then okay. So then, okay, if Q is equal to 0, then we would just return 0 because that's the corner. Maybe that's the only case. So then now we just have to figure out if it ends on 1 and 2. You're looking for what? If Q is equal to, okay, so now let's say, so what we want is find LCM, right? LCM is equal to P times Q over GCD of PQ. I think it's actually in math. Is that right? I guess that maybe this is the one time I can use the autocomplete. Okay, I already knew that though. So then now we have to figure out if it's on the left or on the right. It is on the left if, let's see, we have 0, 3, 6. So technically, it is on the left if Q has to be if LCM divided by Q and if this mods 2 0 we return 2, otherwise we return 1. Maybe that's right. Don't know if that's true, to be honest. Oh, whoops. Thank you. I mean, okay, this is such a base case that I mean, okay. I mean, it's not worth nothing, but it's not worth that much. Okay, so let's say we have P is equal to 3 and we have 2. I expect this to be on the right side, so it should be a 1. Let's see how that works out. And then we want to try, this one should be trivial. And then maybe say like 4 and 3, so then it'll be 12, which is on the left side maybe. Okay. Oh, news. Oh, did I not have a 0? Okay, so I was wrong on this one. Oh, so 3, 2, even though it's on the right side, now we have to check, okay. Now we have to check now we have to check the number of reflections on the other side. Okay, so if this is 0, that means it's on the right side. Then we have to check, and of course, this is a little bit cheating in the sense that if you had on a contest, I would not have been able to kind of get a answer to verify. Probably would have eaten the wrong answer. But oh, I guess my output's still wrong, isn't that? P. So let's say we have 6. So that's 2. Maybe this is reversed. Oops. Doesn't make sense though. Hang on. 3, 3 is always going to be. Whoop. No, this feels more right, even though it's not right enough. Okay, so the LCM is the number of time it bounces until. Wait, which one is 0 and 1? Oh, wait, 1 and 0. So we only care about the vertical portions, and we're bouncing off at 6. Okay. At because that's the number of scenes. So it should. Now this should be. Oh, I'm just being dumb. I'm returning the wrong number. Wait, no, I'm putting the. I'm rushing a little bit. I think it should be here. That's why. Okay, that's why stuff is a little weird. I mixed up the conditions a little bit. Okay. Okay, cool. Yeah. This is one of those problems that are more annoying than it should be. I end up taking about 12 minutes. I think this is heavy on visualization. So I'm going to try a little bit to incorporate, which we call it. I'm going to explain it. Okay, well, let's go over the complexity first, and I'll explain how I came across this answer, which looks really ridiculous, to be honest. And it's like 4 lines of code or whatever. But so the complexity of this is obviously way. I mean, I don't know. It's just all of one kind of. In that GCD technically takes log n, where n is the number, kind of, or I mean, roughly speaking. But effectively constant, I guess, for a number that's not a big int. In Python, I don't have to worry about overflows or anything like that. And everything is all of 1 as a result, right? So yeah. Oh, thanks for follow, Roquel. Maybe Roachwell. But yeah, I'm going to try to get my paint up so I could kind of at least explain this problem a little bit, because it is kind of interesting a little bit. Okay. I do. I mean, or at least I. I mean, it's a really annoying problem. Definitely, especially on an interview. But definitely for a non-interview, it's kind of fun to look at in retrospect, perhaps. But yeah, let me put in the paint up. Hold up. Okay, so hopefully, let me move this a little bit away from the code. Is this the, hang on, technology is hard. Okay, cool. Yeah. So the way I would think about this problem is that, so one thing about, I don't know, I think I actually read something about something similar lately, where, so I don't know if I could reproduce this, to be honest, but okay, given a square, So we have this p here. And then you have some bouncing numbers q or bouncing color q, right? Oops. Oh, there's a straight line. And then you have like something here. So the way I thought about it was, well, let's say you have something like this, and q is 2. So let's just label this q, right? And instead of worrying about instead of doing this, where you bounce off here and then you bounce off here and then you bounce here or something like that, right? So the way that I was thinking about it is, I would actually instead just extend. Oh no, what did I do? Did I delete stuff? Oh, paintbrush. But in any case, I'll draw it back. Oh my. This. Okay. Well, mistakes were made. Okay, I don't know how to get it back. But okay, but let's just say you have someone like this. Let's put the P back. And then you have a line, right, that goes maybe to the right side. And the way that I thought about how the mirror works was kind of just extending it to another square that's like that. And then in that way, then different properties would come up, right? And that's kind of how I drew it on my kind of piece of paper. I don't know if you can really see it that well in any case. I mean, I just kind of... Anyway, but it's the same thing that I'm drawing on Thingy, on the paintbrush. And then what does this mean, right? So what this means for me was that, okay, well, yeah, so there are a couple of cases where, yes, so you have something like that, right? So as we talked about before, I think there is a slightly, hey, what's up, Scatty, 45. So you know that, so first of all, we're trying to figure out if it bounces to the left or to the right. And and after drawing it out, I don't really have a good mathematical explanation, but after drawing it out, you know that bounces to the left if, if it bounces to something like that, it bounces to the left if there are an even number of bounces, which means that if you do the GCD, and that's what the code comes in. Let me look at my code for a second. Where if you look at the LCM, which means okay, so it's going to hit one of the corners on the LCM of P times Q, because otherwise it's not an integer number, right? And or if it's an integer number, it's not because okay, so it only hits one of the corners if the line hits one of the edges on left or the right, where the height is a multiple of p, right? So that's kind of the logic. And then so in that case, and let me know if y'all have questions, because I am sure I'm not explaining this perfectly well. But in that case, it's going to be either on the left or on the right, and the height is p, right? Because this is a square, to be clear. So this height is p, right? So that means that you're going to do this intersection the way we'll meet a receptor only when the height is p. So you can almost do like a simulation, actually, if you, because I think p and q is less than 1,000, so you can have simulators actually. But that means that you add q on every bounce until that q is equal to a multiple of p. So that's how I would simulate it, even though I end up using LCM and GCD. It's the same logic, right? It takes q units to go to the right, and then it takes q units to go back, and then so forth. And then it's on the left if it bounced back and forth even number of times, and then it's on the right if it bounces back and forth odd number of times. And that's kind of what this first if statement does, which is that once we match, if it bounces an even number of times, then we want to return 2 because it's on the left, and then if it's on the odd, then we want to, well, check this other thing. And then similarly, how we kind of came across the height portion is, given that, well, I mean, if it's on the left, then it's on the left, and it's the receptor is always going to be 1. If it's on the right, however, and that's also the only place where it could go back from where the way starts, or variations on it. So if it's on the right, that means that you could kind of look at this, well, look at this bigger one, right? On the left, the graph that I have. So it's going to be on the equivalent of the bottom, which is receptor 0, if and only if it does an even number of kind of square copies, right? And if it's the odd number of copies, then it'll be on the receptor 1. So that's kind of how I thought about it, and that's where this magical formula comes from. Yeah, that's kind of my explanation. Let me know if you have questions. I don't think this is a easy to visualize problem per se. I think looking back, especially looking at the bounds, I would have this, especially for a medium. I think for a hard, what I did is maybe more acceptable, maybe a little bit, or at least a really hard medium. But given that this is a medium, and given look at the bounds, you can actually simulate this, and yeah, you have simulated Q, and then it just keep on going. And because Q is less than 1,000, and P is also less than 1,000, then like your biggest number of iteration is just the LCM of P times Q, or the LCM of P and Q, which is roughly slightly less than 1,000,000, right? So that would be fast enough in those cases, probably. And then you could kind of work out which one it lands from that way in a more kind of intuitive sense, and then you could generalize to kind of what I did, even though I skipped ahead a little bit, as a result. Cool. And I think maybe in retrospect I need this now, but that's fine. Cool. Yeah, overall probably a very, I don't know. So both, you could think of this either as a geometry problem, or like a mathy number theory E problem, both of which I do not expect to be on an interview. But I mean, I don't know. I'm locked to see the companies, but apparently, I feel like last time I said that, someone was like, "Oh, this." They say that this will be an interview, so I don't know. But I would not expect it, and probably there are better things you could study than this problem in any case, until, unless you're really good at everything else, then maybe you could play around this problem. But yeah,